Catus, Maximus here. This time just a quick video about the Milwaukee 1001. I only paid 15 bucks for this D-handle drill. We know this is a older one, probably from the 70s or so, because of the design of this body. Newer ones in the 80s or early 90s, they went to the more flat-sided with the vertical vent grills. The really old school, like 50s and 1950s and 1960s Milwaukee drills had a metal housing or handle that looked exactly like this. Then they just switched to plastic, and then they changed to plastic on them. These are the ubiquitous Milwaukee D-handle drills. D-handle because it looks like a letter D. These are good for repetitive drilling operations because, of course, your hand is in the center line of the chuck. It also makes it easier to actually drill a hole, either level if you're holding it this way, or absolutely straight up and down if you're holding it this way. It's one of the nice things. Of course, the issue with these drills, especially half-inch ones, is the handle doesn't stick down. Very easy to twist your wrist and sprain your wrist on these. So you put on a side handle. This is an older one. We have no bolt holes in the gear case to put in a side handle, so you have to use this special type of Milwaukee pinch type handle, and I happen to have an extra one. The collar diameter is also a little bit bigger than what would be considered standard, so a lot of other handles just simply won't fit. What makes this one a little bit different is it happens to be a 600 RPM one, and it is new enough where they moved up to the 4.5 amp motor. The earlier versions with the metal handles only had 4 amp motors. 600 RPM is a good RPM for a half-inch drill, but it's actually more unique. Now, with these D-handle drills, this is the same drill as what Milwaukee uses in their 1107-1, the right angle. I think it's the 1107-1, the right angle drill, but that happens to be a 500 RPM triple gear reduction D-handle drill. They also had, and I have one, but it's buried right now, a very low RPM 350 RPM unit, which was like a plumber's drill. Most of them tended to be triple reduction 450 RPM units, and then when they went with the newer ones, like in the current model right angle drills, they went up to 500 RPM mainly because they increased the motor from 4.5 amps to 7 amps. So a more powerful motor just spins a little faster. I think they even have the same gears. This one, we know it's a double reduction. You can just see the fan, so when I turn the chuck, the fan moves in the same, the motor moves in the same direction as the chuck, which means the motor comes in, turns an idle spur gear, which then connects to the chuck. Triple reduction gear drills are pretty easy to tell because when you turn the chuck, the motor will turn in the opposite direction, indicating that there's 2 idle gears. And that's simply because it's 600 RPM. What we'll find in this gear case is it'll have casting provisions to be a triple gear reduction, 450 RPM. But that's what's kind of neat about this is just the fact that it's one of the higher RPM ones. I think they, at least in the current models or in the last couple of decades, they've also made 900 RPM versions of these. But pretty much everybody who buys these bigger Milwaukee drills, or pretty much from any manufacturer, gets the lower RPM, higher torque models because that tends to be what they're using them for. 600 RPM has been a, half-inch drills really are 450 RPM, 550 RPM, 550 RPM, and 600 RPM. It's just been like that range has been the standard for probably a century. It's just the half-inch drill range speed. So having a 600 RPM one, it's just a little bit faster. The big deal about this is just the fact that even though it has what would be arguably a pretty weak motor, only 4.5 amps, you just have a lot of heat sinking ability, really big commutator and large oversized brushes so they can really deliver the energy with lower resistance, and they can just take a lot more heat and a lot more continuous kind of abusive operation. Did lube the switch here. And I kind of want to demonstrate that. Now, I did a video more recently of this Black & Decker 7 amp half-inch drill. This is, even though this is a triple reduction drill as well, but it happens to be 900 RPM. And it was able to drive through a piece of Douglas fir pine, this 2 9/16, that would be like 65 millimeter self-feed bit, and it was able to this Black & Decker was just able to drive this bit. It got jammed for like half a second, and the this Black & Decker is able to pull through and finish the hole. And so I wanted to show just a difference in of what would be considered 33% less RPM, or the Black & Decker is 50% more RPM. How am I trying to say this? This should be able to drive this bit easily as well as that Black & Decker, even a little bit better, because the proportional difference of the RPM and amps should play them on paper about even. Although the motor in this Milwaukee, even though it's lower amperage, it has a lot more mass than the higher amperage motor that was in this Black & Decker. And the reason I mention this is a cheap drill, but it's actually all ball needle bearing except for the main spindle. All the idle gears and everything are all needle bearing, so it's actually surprisingly okay for a cheap drill, and it actually did drive one of these bits, which was surprising. But I wanted to show what, you know, heavier duty Milwaukee can do, even though it has a much weaker motor. Now, of course, the biggest disadvantage to these older drills, pretty much all manufacturers, is that having a reverse capability, like on these Milwaukees, on the newer ones, there's just like a switch right here, is that they just didn't include it. It's not a technical issue with the universal motor, it's just that they didn't, it just wasn't something standardized until 70s or 80s. It was surprisingly late. Really annoying how so many of these tools just do not have a reverse function. So if the bit gets jammed and a drill that doesn't reverse, is just a hassle. You gotta loosen the chuck and get in there with pliers, or, you know, God knows what. Anyway, give this a run. Milwaukees always sound really nice. So let me move this more into the position here. And I'm going to brace myself here. And it's going to want to go the opposite direction, so I'm going to take this handle, put it against my leg, and this should blast right through it. That Black & Decker is what made this hole, so you can go back to that Black & Decker video to see how it sounded and struggled versus this drill. It's definitely struggling. Oh, just ran out of gas. Come on now. And that's what can happen. It was just able to do it, but then I got a little bit of an angle and it jammed it up. Alright, gotten this loosened up. Let's see if we can't continue. So you can see that was quite literally right at the limits, right about the same as that Black & Decker drill. The difference is it will really push through, and I should have had a power meter so I could have measured that, but this I'm sure was drawing a bit more than 4.5 amps during that cut. This bit is way larger than what this drill is rated for, but it's kind of what gave Milwaukee the kind of reputation that they had, was just the fact that the drills could really, you know, as they say, punch above their weight. And this certainly did too. It was really struggling, but it didn't sound horrible, and no weird, crazy smells. It just sounded like a tool that was really working hard. Now, of course, it did get stuck, and that was the big issue. Wish this thing would have had a reverse. But this thing is really optimized. Really, I would say this would be perfect for drilling in steel. Drilling in mild steel with a 1/2-inch drill bit, you're supposed to be running about 720 RPM. This is a little bit slower, but it would be great for, once again, 1/2-inch size holes in steel and other general kind of drilling duties. Just 65 millimeter or 2 9/16 self-feed bits may be a bit much for regular usage. You may overheat it. Taking a quick look-see at the electrics here, if we can get this thing to... There we go. Very old school. I don't know what this is, if it's Bakelite or what kind of plastic it is. Anyway, we can see the most annoying part about these old Milwaukee drills is that the strain release is overmolded into the power cord, and so it's kind of a funky process to find just the right strain relief and to replace the power cords. Do have metal inserts in the handle. More or less modern switch. These switches are the same, or would fit in the same single-speed drills made decades later. This is back when the motors were a little better. They did fabric wind the fields, which they don't do anymore. Welded contacts on the commutator. We can see a nice string protection. Wires are a little dark on this drill. I probably darkened them a little bit more, but you always know if a motor's starting to burn out, not just because it seems to have less power, but when these wires start to short out, you'll get a lot of sparking around the commutator, and it will want to repeatedly stall in the same position. Some windings will burn out, and so it'll come around and then want to stall, and then come around and then want to stall. And we can see this has a huge diameter compared to my finger. That's probably 1¼ inch diameter commutator, just way oversized. And even doing that drilling, this just has a huge amount of heat capacity. It's only sat for just a couple of minutes, and I can easily touch the field windings, even the commutator itself. And as far as low sparking, let me show you. All power tools are going to have some sparking. Bigger, like 15 amp motors and big saws will have a bit more sparking, but you shouldn't see like plasma balls, and so that's kind of why I'm going to demonstrate here carefully. But something that's running well and doesn't have a burned out motor, this is exactly what it's going to look like. Especially on a Milwaukee, it's just going to be just a bit of a tickle of sparks right under the brush. And yes, for consistency's sake, I'm using an old school Stanley 100 Plus series screwdriver. Proper forged screwdriver for this tool. And we'll take a look at the gearbox, which has not been disassembled in quite a long time. That thing did not want to come out of there. So, as I was speaking earlier, we can see that there's a provision for, because this gear case is going to be used for all the different RPMs, and if it's a triple reduction, they'll have just another gear and bearing here. As we can see, this is an old school unit. Every video I need a flashlight, I never have one. It always annoys the beans on me. I like these older ones because the needle bearings, as you can see, aren't caged needles. They're uncaged. Just a ton of needles. I really like that because it's just a bit heavier duty. As we can see, nice spiral cut gears, helical cut gears. They'll be on both stages. This is going to be the original grease, and that's what I mean by one of the things Milwaukee does, and they have set themselves apart, is they put tons of grease in their gearboxes. And this is no joke right here. This isn't somebody who went crazy. I've taken apart dozens of Milwaukee tools, and they all have tons of grease in their gearboxes. One of the ways they get their gears to really last a lot longer is they just don't chintz on the grease. It makes their tools heavier, and yeah, it's a bit more expensive, but it really can be one of the things that does make a tool last so much longer, is just having much better lubrication, longer lasting lubrication. We can see what was happening is this gear was wanting to kind of come out, pushed it back in. Now what Milwaukee does is they have needle bearings on the back, but on the front of this gear it's a ball bearing. Since it's helical cut, there's going to be thrust loads, and in this case, in a normal direction of operation, those thrust loads are going to be forcing this gear towards the front of the gearbox, so they use a ball bearing to both handle the lateral loads and the thrust loads, give efficient power delivery. And before I forget, Milwaukee's always proper. There's a little hole in the front of the gear case. That's for this alignment pin. That way, when you take apart the gear case and you put it back together, whoop, you're not even in, you can't even see what I'm doing there. When you put it back together, it makes sure that these, both the diaphragm, the back of the gear case, and the front of the gearbox stay absolutely perfectly aligned. Because with gears, you really want, whether they're helical cut I should say that would be an angle helical cut or a straight cut, you want them to interact and be absolutely parallel so the pressure is across the entire surface. And it's really been one of my big complaints about Makita drills. And a lot of Makita tools, not all of them, but a lot of Makita tools, in particular their drills, they don't include those alignment pegs. A lot of other manufacturers also don't. And it's really annoying because when you put the gearbox together, when you shift when this front when these two halves are rotated, what it does is it will cause those gears to get a little bit cockeyed. They're in there like this, and so when this twists, what it's causing is the gears to want to rock back and forth. So that's what makes the peg so important, is it makes sure that they go back in and they stay exactly as aligned as they were before. The problem with the gears getting cockeyed is when they get cockeyed, what ends up happening is you have a misalignment, and so you have one part of the gear where most of the pressure is. So it puts a bunch more load, concentrates it on a small area. That portion of the gear starts wearing out faster, and as it wears, that pressure point just crawls across the gear. And gear alignment is most of what determines the lifespan of the gears, not just like the metal or the heat treatment. If they're really well ground and aligned perfectly, then their pressure will always be nice and even, and then that will greatly reduce the wear. Anyway, I like this drill. I mean, these old Milwaukees, I did go ahead and refresh the grease. I didn't completely clean it out, but I scooped out all the dark grease and put in some fresh grease. Certainly sounds really smooth now. As it's pumping all that grease through. Really wish this had a reverse, but this is one of the nice things about a drill like this, getting the feel for it with that 2 9/16 bit with the side handle. This 4.5 amps at 600 RPM is actually really well balanced for the amount of torque. You know, you get some pretty good efficiency at 600 RPM, and the amount of torque is, you know, once you have a feel for it, it's something that you can more than control with this stubby side handle, and it's not something where it's could potentially be, you know, really dangerous, or if you're not paying attention, could really twist your wrist up. It once again is just a nice balance of torque and RPM. And I actually really like this drill, this 4.5 amp 600 RPM unit. And there's just so much mass in the motor and so much ability to sink away heat with the aluminum housing. The fact that it just has, a ton of airflow, you know, 360-degree venting. I could probably drill this, you know, use this on a construction site and just drill dozens and dozens of those 2 9/16 holes, and it would probably get pretty hot towards the end of, you know, several hours of use. But it would actually take it and absorb it, and that's one of the things that makes these old Milwaukees beautiful. As far as corded drills, Milwaukees were really, really good, and that's why I like talking about them and making dedicated videos about them. So many companies put heavy duty on their tools, and they never really quite matched up to what a Milwaukee would do, RPM to RPM and ampere for ampere. Anyway, really appreciate everybody who's been watching and subscribing, and if you haven't subscribed, please do. Until next time, Catus Maximus out.